Good afternoon to everyone. Sir, HOD sir, shall we
Yes, ma'am.
shall we start, sir? Uh,
Yes, ma'am. Please start, ma'am.
yes, sir. Vaishnavi, please introduce the resource persons.
Yes, ma'am. Good afternoon, everyone. Here, the world is full of diamonds and gems, and we are having some of them here today to build this event. So, by this note, I would like to give my grand welcome to all on behalf of Sri Venkateshwara College of Engineering, Tirupati, Triply Department. Today is the last day of training sponsored by AICT 1 week short term training program on research trends in renewable photovoltaic system and its research challenges. As with all your cooperation and patience, 5 days of this training completed successfully. And now I would look forward to you having a pleasant stay and a nice learning experience here. With these words, once again, I welcome you all. By the way, before going to start the session, here are some instructions. Do follow them. So, everyone are requested to mute your microphones and turn off your cameras. And everyone are requested to pin the resource person screen and listen the session, make down the key points and post your queries in chat box. During the query session, all the queries will be answered by the resource person. And now, let me welcome the man who doesn't need any introduction and known among all of us for his wisdom and his knowledge. He is none other than our strength of Triply Department, Dr. Sudhir Kumar Sir, SVC. And next, we look forward for the presence of resource person, right? Yes, as today is different from the previous days, as the training is attended by two resource persons representing both on Rooftop 400 kW PV power plant established in SVC campus by Dr. Sheikh Rafikiran and by Mr. P. Venkatavaraprasad. So firstly, I would like to give my heartiest welcome to Dr. Sheikh Rafikiran, working as professor and head of the department Triply SVEC. He completed his BE in Triply from Bangalore University and had his MTech and PhD in control systems from JNTU Hyderabad and JNTU Anantapur respectively. He has a very good teaching experience of 20 years and ratified as professor from JNTU Anantapur in 2016. Sir has 2 patents on his name and also has more than 40 plus journals and 5 conference publications in international level. Sir guided MTech and BTech projects around 30. He also published a book by international publishers on system identification using adaptive control system. Sir organized FTPs, workshops and seminars too. He awarded as Emerging Leader by Venus International Foundation. And now, here, it is a great pleasure to welcome the second resource person and also a noted personality, Mr. P. Venkatavaraprasad. Obtained MTech in Electrical Power Systems from ST Mayers College of Engineering, JNTU Hyderabad, and followed by BTech in Triply from Engineering College affiliated to JNTU Hyderabad. At present, Sir is working as assistant professor in SV College of Engineering, Tirupati. He has 10 years of teaching experience and 2 years of experience in industry. He done project at Hairkandivadi site, Karnataka, 13.5 megawatts, and also at Bhima Samudra site, Karnataka, 39 megawatts, which is worth of 120 crores and 330 crores. He has experience in substations and transmission lines as a site engineer in Get Engineer Construction Private Limited. He worked as wind mast erection engineer for 3 wind masts, which is in around Chitradurga, Karnataka. He did signed line diagram of 220 kV substations in Karnataka and it was approved by government. So, a person of such great magnitude is truly inspires. Now, I welcome both the resource person, Dr. Sheikh Rafikiran sir, and also P. Mr. Venkata Varaprasad sir, to take up the session. Welcome, sir.
Thank you, Vaishnavi. First of all, I would like to thank Dr. K. Sudhir sir, Dr. K. Kumar sir, and co-conveners P. Sunita ma'am and Y.V. Krishna Reddy sir for giving this great opportunity. Well, coming to the session, so this is an real-time project, so which is erected in SV College of Engineering. So first of all, I would like to intimate one point here. Every slide is interrelated to the other slides. So every point is more important to for the who are going to do this such kind of projects in their institutes and their organizations. So every slide is very useful to everyone. Please carefully listen. While coming to the session, so here grid interactive rooftop 400 kilowatt solar power plant at SV Sri Venkateswara Colleges, Tirupati. So basically, the rooftop systems are classified in three categories. One is standalone systems. So the system is not connected with the grid and designed to work only with the storage system. This type of system, everybody will know this. So storage system is nothing but battery storage. Next system. This system works in conjunction with the other sources such as a diesel generator, wind turbine, and storage system to support the load even during a power failure. So this type of projects are many members have done. So this is also well known. So next one, grid tied system. So basically solar power plant is classified into two categories. One is off grid, another one is on grid based. So this on grid, that is a grid tied system. It's a very useful to the different type of organizations because the power consumption will be reduced and those organizations doesn't depends upon the grid. Okay. So grid tied systems, these systems are designed to supply the generated power to the grid besides local loads. This system will not generate power during a power failure as they need to be synchronized. At the synchronized condition only, the power will be generated. Otherwise, the inverter will be off-grid status. So this is a simple one diagram, grid-connected PV system. Here you can see the solar PV array, so solar modules with the supporting structure. So what are the power generated from the modules that is connected to the inverter? From the inverter, the DC power is converted to the AC. So how much power is generated from the module and present how much power is transmitted to the AC system. So those kind of things we can easily monitor in this inverter. Okay, and that AC power is connected to the main utility breaker panel. From the breaker panel, you will connect to the local loads. And another point, you will connect to the grid. Here, based upon the demand on local loads, whatever the power generated from the solar power plant, so that will be utilized by the local loads. And the remaining power is sent to the grid. So through the utility meter. So here utility meter is a bidirectional meter. So how much power we are imported from the government and how much power we are sent to the government. So those two data will be stored in that utility meter. So then we can identify how much power we are generated and how much power we are sent to the grid. At the same time, how much power we are utilized from the grid at the same time from the solar power plant. So those total data will be available in the utility meter. Next. So first of all, let us know the advantages of rooftop PV system. Welcome to our side, that means consumer level. So five main things. So everyone will target on the energy bill. So here, by erecting this rooftop PV system, the energy bill will be reduced, and reduced the dependency on grid, sustainable energy source. Welcome to the discom level, reduced consumer demand. So because we are generating the power now, so the consumer demand in government's that government side, demand will be reduced, reduced losses due to reduced power flow. And welcome to the national level, easy to meet national targets such as renewable energy targets, power for all, etc. Reduced requirement of land for addition of solar. So welcome to the our concept main. So this is an erected one. So SV College's rooftop solar power plant is also having the capacity of 400 kilowatt on-grid solar power plant. So from here, so till now we are seeing just an introduction part. So what is meant by rooftop, and so what is the advantages, how it will be connected. So this is a major and our main concept. So on-grid solar power plant in SV colleges. So for installing this solar power plant, so initial amount, the invested amount is 185 lakhs 70,000 to 86 rupees. And from the government, there is a Solar Energy Corporation India is given the subsidy amount is 33%. That is a 61 lakhs 14,900 rupees subsidy amount is provided by the government. So here in this rooftop, total number of modules are erected is 1,215 modules. So each module having 320 watts. So daily, this total solar power plant will daily generation, average generation is 1,728 kilowatt hour, and monthly average generation is 51,840 kilowatt hour. At the same time, average annual generation 6 lakhs 30,720 kilowatt hour. The average saving units per month is 32,800 units. And average saving amount based upon this saving units, the approximately so saving amounts will be per month is 2 lakhs. And efficiency of energy conversion of each module is 18%. So here you can see there's a rooftop solar power plant in SV colleges. So in each and every block, so number of modules you can see here. So here in this college, total 10 blocks are there. In that total 10 blocks, each block is erected with a rooftop solar power plant. Based upon the space availability on this block, so we will erect a number of modules. So availability of space, so number of modules will be increases. So the availability on space, so the inverter capacity is decided. So if more space is available, then we will erect a near 50 kilowatt inverter. If less space means we can erect 30 kilowatt inverter. So that's enough. So like this, two types of inverters are available in this power plant. So before erecting a solar power plant, we need to follow some terms and conditions of energy generation. Welcome to the estimated units and performance ratio is measured at HD and LT side under the following conditions. So first one, availability of grid and auxiliary power is 100% when the array is generating. Second one, the performance ratio of the plant is calculated on the basis of global inclined radiation measured in kilowatts per square meters from the simulation report. This report is produced by this particular installation company. So based upon that simulation report, we can get this performance ratio also. So this performance ratio will be shown in another slide. Okay. The estimated units and performance ratio thereof is based on a global horizontal radiation, global inclined radiation, and a temperature as indicated in a PV system simulation report. And fourth point, any variation in the solar radiation and temperature insulation value will have direct impact on energy output from the plant. So next one, degradation factor is considered in line with the degradation percentage as indicated in the manufacturer's data sheet of proposed solar module. So this also provided by the particular installation company. So degradation factors. So this degradation factor is nothing but a depreciation percentage. We have well known that one. So every electrical equipment year by year, its performance will be reduces, is it? So that will be shown in percentage. That is a degradation percentage. Okay, this also I will show you later. And sixth one, the estimated energy is measured at LT and HT panel at the plant output. And last one, all energy performance numbers will be estimated during FAT based on a mutually agreed standard test procedure as per IEC 61725 with temperature correction. As this technical report is given by National Renewable Energy Laboratory. Okay, so this whatever that as per standards. So what is the condition of energy and performance ratio? This everything is tested by the National Renewable Energy Laboratory, and or as per the agreed performance test procedure. So here you can see there's a solar power plant, how many modules are there, and each block how many modules are erected, and each module having the capacity of 320 watts. So first, let's say here the block 1, it is having the module capacity of 320 watts, and a number of modules are erected in this block 1 is 140 modules. While calculating this one, 140 modules with having each module having 320 watts capacity, then we will get the DC power 44.8. At the conversion, so AC will have 50 kilowatt. In the same way, block 2 having 108 modules and block 3 having 140. Like this, total 10 blocks are there. 10 blocks, sorry, 10 blocks are there. So while summing this total modules, so number of modules in this plant is 1250. So which is having the capacity of 400 kilowatt. And so I'll come to the technical specification. So technical specification of 320 watt multi-crystalline modules. So you know that types of modules are there. So here design, the silicon cells design. So crystalline silicon cells, the polyphonic are there. So different types are there. Here we have taken the multi-crystalline modules. So here the general information is so total 3,250 multi-crystalline modules are there, each one having 320 watt capacity. This specification covers the minimum technical requirements in respect of design, engineering, manufacturing, inspection, testing, and performance of crystalline silicon photovoltaic solar module to be installed at 400 kilowatt solar power plant at SVC Tirupati. So here the design criteria. So location SV College Tirupati. The maximum ambient temperature 45 degrees. Minimum ambient temperature in that site is 8 degrees. And wind zone 180 kilometer per hour. And you can see here site latitude and longitude points. Okay. So before erecting any power plant, before that we need to get an basic information. What is the temperature ranges? How much wind speed is there? Because if a wind speed is high, means it may damage at wind season time. It may damage modules and it may damage controlling equipments also. So we need to get this information: how much wind speed, maximum wind speed is there at that particular wind season, and how much temperature will be produces the particular season wise. So every data we need to collect before erecting a power plant. It may be an solar power plant, it may be an wind power plant, anything. And the system description. The required number of PV modules will be connected in series and parallel combination to form a string. So please, everyone notify that point, string. So form a string, keeping in the view of further distribution and protection before connecting to string combiner box to achieve desired capacity of the project. Module shall be placed at a fixed tilt on the site location and design requirement. Module shall have only positive tolerance. So this type of modules will have only positive tolerance, that is 0 to 5 watts of module. Okay, so here the tilting that module, so that in which direction we will keep, everybody knows that one. The traditional advice to position the solar panels to the south facing. This is because for those of us living in the northern hemisphere, the sun is always along with the southern part of the sky as we complete our yearly orbit around it, is it? And here, the required number of PV models will be connected in series. So, a basic concept, if you want to increase the DC voltage, that's it, by taking in batteries. So, if you want to increase an voltage level, what we will do? So, number of batteries are connected in series. If each battery having the 10 volts, so if you want desired output is 40 volts, then four batteries are connected in series. Okay. So if the series connected is one set, and the number of sets are 10 is there, then the 10 sets are connected in parallel. Is it? Because the total system will be maintaining the 40 voltage common. Is it? In the same way, here we will take the each module as a cell. So for getting a desired voltage, the total modules are, for getting a desired voltage, so number of modules are connected in series form. So that series form connected modules is nothing but string. It's a very important. The series connected modules are said to be the string. Okay. So those number of, so for example, 18 modules are connected in series. That 18 modules are said to be in one string. So that kind of strings are available in that particular site. It may be 10 or 20 like that. Okay. So here you can see the string inverter configuration. So here the yellow indication is nothing but modules. So those modules are connected in series. So here three modules are connected in series. This is said to be in one string. And here three modules are connected in series form. That is one of the string. So these sets are connected in parallel and is connected to the combining box. That means we are saying it is an array box. So I will show you later. So this series connected strings, series connected modules are said to be string. These strings are connected in parallel form. Okay, so you can see there's one string configuration, another string configuration, another string configuration like this. Okay, so you can see this, the modules are placed like this, one by one. So this total modules are connected in series form. So this total modules are said to be one string. Specific design requirements. So PV module shall have 72 number of multi-crystalline silicon cells. So each model have 72 number of multi-crystalline silicon cells of size 156 mm into 156 mm size. All the modules are supplied shall have 100% compliance to cell design of either a 3 bus bar or 4 bus bar at front gate. Here in practical, so whatever the erected modules are there, it is having 4 bus bar at front gate. The supply of fixed quantity of modules with both design shall not be accepted. Front glass shall have high transmission, low iron. So if iron contains more means it's a module body temperature gets increases, is it? So that's why here the low iron tempered glass, which is having the thickness of 3.2 to 4 mm thickness, and preferably with anti-reflective coating. So here you can see the model specification. So this is each model having each model specification. So it's having the maximum power 320 watts, open circuit voltage 45.30, short circuit current 9.42, maximum power voltage 36.8, maximum power current is 8.7, and maximum system voltage is 1000, and weight of the model is 25.5 kg, and a dimension. So this is very important for estimating and solar power plant. So dimension of the module is plays a major role. Okay, so the dimension is 1956 into 992 into 40 mm. So in this way, so total modules having this type of specification. And he can see the plant design. So before erecting an solar power plant, we required this type of one estimated design. So here you can see the number of strings are connected in series form. That is number of modules are connected in series form. That is the string. So this types of strings here I mentioned 9 strings. So 9 strings are connected to the monitoring box or combinary box, or we can say array box. Okay, string monitoring box. So in parallel form. So like that, 3 string monitoring box are there. So each one is connected to the inverter. From the inverter, it is converted from DC to AC, DC to AC, and that AC is connected to the circuit breaker. So for protecting purpose, we need a breaker. And in parallel, here you can see the SCADA system. From this SCADA system, we can get that each inverter status. So present, what is the condition? It is off grid and on grid, or what is the present radiation value, temperature, and wind speed. Everything you can get from the SCADA. This is an online communication system. From the inverter, whatever this AC power is there, it is connected to the breaker, and from that breaker, it is connected to the common busbar point. From this busbar point, you can take a protecting device. One is a relay is there, and also it is connected to the surge arrestor. From that protecting device, again we will connect it to the one busbar. So if any failure occurs, then we can simply isolate this point. So then we can work on that one. So for that purpose, we need to provide a breaker. So after this copper bus bar, again it is connected to the distribution side, LT panel. For before erecting a solar power plant, first of all, we require this kind of line diagram. And here you can see the mounting and string cable points. So here you can see the number. So this is in block 8. Block 8, it's having the string 3 and 4. That means whatever the string 3 is there, some modules are placed in this place, and for the string 4, some modules are placed here also. So that's why they are mentioned like string 3, 4. At the down point, you can see the cables here. So this 2 string cables are taken from here. And those strings are connected to the array junction box. So here in the down point, you can see here the strings are there, the cables are there. This is nothing but string cables. Here I can see that nearly 7 cables are there, 7 strings are there in that particular block. This positive string cables are connected to a fuse point. For protecting purpose, we required a fuse, and this fuse is connected to a bus bar. Here you can see the bus bar top point. You can see a bus bar. From this bus bar, another positive connection is there. It is given to the inverter. I will show you later. So here, this positive strings are taken from the modules. Each one saying as one string. So that is connected to the fuse. From the fuse, it is connected to the bus bar. From the bus bar, another positive connection is there. From this, we will connect to the inverter. At the same time, you can see the negative polarity. From the string, we will get the positive and negative. So this negative polarity is connected to a bus bar. From this bus bar, outgoing side, that is connected to the inverter. Here you can see the inverters. So 2 capacity inverters are there. One is 30 kilowatt, another one is 50 kilowatt. That's it. So here down point, you can see the cables are there, which is taken from the array junction box. That's it. As for the given directions, so we will connect the positive and negative cables below side of this inverter. From this inverter, the DC power is converted to the AC. And here you can see the 4-core cable, 4-core cable connecting point. So this 4 cable went to the AC distribution board. You can see here, solar AC distribution board. So this is the closed one. And I'll open this one. You can see like this. So here the three-phase system. So we are getting the supply or not. This will indicates RYB three-phase system. And here you can see the breaker lever point. So if you want to trip the device, that means if you want to stop that solar power plant, if you have any maintenance or any failure occur, then we will simply so off this one. Present it is in on state. You can see here on state. So while turn off this one, you can simply do any maintenance work on any repair works or like this. And here also we're having the one monitoring device. So how much power is transmitting and what is the voltage status and what is the current status and frequency, power factor, everything we can monitor here. Well, open this one, you can see the inside of this AC distribution. Here each phase indication is there. You can see here R, Y, B is this three phases are connected with a common neutral point is there. And this is a metering device. So these connections are taken from the CT point. So here it is a breaker inside. So initially I'm showing this one. The lever point is in upward direction. So it is in on. So if you want to turn off this one, then like this. So present it is in off state. You can see here off state position. Is it? So this is a breaker here. And this is the incoming three-phase system from the inverter RYB three-phase system. It is taken from the inverter. So this is a breaker and this is a breaker output side. So here also we are taking that three-phase system RYB, and this is nothing but internal current transformer. So for measuring the status of power generation, what is the current status, voltage. So particularly every meters is required the current, mainly is a current coils are connected in the inside the meter. So here ICT is there. So from the ICT here you can see the black cables which is connected to the meters. And inside of this one, here you can see one device is there with an red LED. Here you can see a box. So this is nothing but a communication device powered by the Flexi MC company. Whatever that status is the power generation, or is the power generation, what is the current what is the present voltage, frequency, power factor, and everything data. So we can monitor through the Flexi MC monitoring system. And here you can see the total control unit. So first one, this is the array junction box. So this is a positive polarity which is taken from the string, and this is a negative polarity which is taken from the string. So this positive also connected through the fuse, connected to the bus bar. Here negative bus bar, it is taken the output, and these two are connected to the inverter. And from the inverter, it is converted from DC to AC. The AC 4-core cable, it is connected to the AC distribution side. And here it is presented with the breaker. From the breaker output cable taken outside, and it is connected to the main NCB of each block. So each block having one main NCB. So this cable is connected to that particular point. And here you can see that inverter, we are seeing that already inverter. Here inverter system monitoring digital meter is there. We can get the each and every point status. So here you can see that first one on 21st October date is there, the time, and the status. It is on grid. Present it is connected to the grid point, synchronized position, and the power producing 951 watts. Today, that means generation today. So till morning, from morning 6 to it's from morning 6 to present, whenever I'm taking the reading at the time, it's generated 109. When entered into this display, then it's give the options like meter, energy log, event log, inverter info. Well, going to the meter, here we can get the status, three-phase system voltage, At the same time, DC voltage, current, power, and a power factor is a present power generation, frequency, today, E total, energy today. So you can see here 109 kilowatt, here 110. And while going to the life energy, so till now, how much energy is produced from that particular block? So not from the total plant, it is only from the particular block. After its commission on September 14, 2017, from September 14, 2017 till today, it is generated 1 megawatt hour, 1084 hours. And when enter into the energy log, while going to the energy log, here we'll get the three options: day energy, month energy, annual energy. Well, enter to the day energy. Each day, how much energy is produced? So 21st October, it is produced 110 kilowatt hour, and 20th 63 only, and 19th 113 kilowatt hour. Okay, like this we can get the data. And here event log. Event means error events, grid report. While going to the error event, you can see here will restart automatically. So this is the solar online communication system. So this is the online communication system. It's powered by the Flexi MC company. So I will show this one. So are you able to see this one? What I'm shared here, Flexi MC online communication system. Sunita madam, can you able to see this one?
Yes, sir. It's visible, sir.
Ah, okay, thank you, ma'am. So here you can see this energy today, energy yesterday, current week, current month, last month, every year. So current year, last year, like that. And also here we are getting the data. So revenue this one, this month, last month, till date after the commissioning this plant till date, and the total energy how much is produced, and how much environment saved due to this power plant, and the weather info, everything will get this online communication from this online communication. And here you can get the status of the inverter. You can see here the status of inverter here. So present, I told you that here 10 blocks are there. So let us say this in admin block, present is in an on grid status, and block 1 also on grid status. So here block 3, there is an communication device fault is there. So that's why it's showing off grid status. And also block 4 off grid, block 8 off grid. So by getting this information, immediately we can attend to that particular block. What is the problem? Is there any communication problem, or is there any inverter failures, or any module problem, like that? So minute to minute, we can easily identify and monitor the what is the inverter status. At the same time, we can get the generation level also. So this is total inverter data. You can see here. So October 1st, how much it is produced. October 2nd, and this blue indication is nothing but energy generation. Orange indication is nothing but radiation value, global radiation value. You can see here. At the time of October 1st, it's generated 1104 kilowatt hour. So till now, how much energy generated, and this is the irradiation value. Like the day wise, we can get the data from this communication system, which is powered by Flexi MC company. And this is totally inverters. At the same time, each one, if you want admin inverter, how much power is generated, and what is the irradiation value. So you can totally generate 1104. From the admin inverter, we got 130 kilowatt hour on 1st October. So total site will have the common irradiation value. No need to check this one. Okay. So here admin block generated 130 kilowatt hour. And here we can see the block one. Block one on October 1st, it is produced 164. 164 kilowatt hour. Well, come to the last block, Girls Hostel block, you can see here it produces 196.2 kilowatt hour, like that. So each and every block we can check how much energy is produced per day at the same time. What is the inverter status? It is an off grid or on grid, and everything we can get from this online communication system. So at the beginning, I answered that solar generation. Here we need to follow some terms and conditions. In the terms and conditions, we have seen that fifth point. The plant performance for its lifetime are 25 years. It should be like this report. 25 years estimated 400 kilowatt is projected performance information. They will give value. So first year 2.5% to next year it's commonly degradation value will be 0.7%. Okay, so here they are given the estimated plant performance ratio. So you can see here. So initially it will be in 76 and goes on. It will be reduced it up to 64.8. So you can see the first year it will produce. They are given the estimated value. Okay, so this is not fixed one because power maybe changes. Some season, sometimes 1 year we will get season will be more like that. So they are given the estimated. So at the first year we may get the energy, second year 600, third year 595, like that. Up to 25 years they are given. So estimated power generation. So while comparing this one, at the first year we got 604. At the time of 25th year, it's getting 510. Well, comparing any electrical machinery, it's not a drawback. It's a better generation only. Is it? We can see this plant performance, estimated performance graphical representation. So you can see from 600 to it's nearly reached to the 500 only. Okay, it's a good performance, I think so. And so after completion of 1 year, just we are analyzed an analysis report on this particular power plant. So this is 1 year data analysis. So it is selected on September 14, 2017. I already told you. So we are taking the October 17th month generation because it's September is our month completed now. So that's why we are not taking that one. So October 17th. So first month we are taking the whatever the power generated from this particular plant. So 41,341. So we are taking 1 year data. October 17th to September 2018. And this is the estimated generation. So based upon the capacity of that particular plant, is with an having the efficiency of 18%, and how that particular month, how much it maybe produces. So this is the estimated value. So maximum 100% efficiency, having 100% efficiency generation. So then we will take this value like this. Okay. So while comparing this one, so this is the actual generation. While comparing these two conditions, we will get the plant performance factor in this way. Okay, so you can see here particularly at January, February, March, April, May, the summertime. So you can see the generation plant performance crossed even 100% also. At the beginning time, I said that the module having the tolerance of only positive tolerance is there. That is 0 to 5 watt Z. So each module having the 5 watt, so the summertime, the irradiation value will be more. So by taking that positive tolerance 5 watt from each module, 2,050 modules have been. So there is a chance to produce more than 100% more than 100% plant performance also. So that's why here in the summertime season we got more than 100% plant performance. Welcome to here. You can see July and August time. So plant performance reduced because the seasons change. So that's why here generation will be less. So overall, in 1 year, so it has to produce chances. It has to produce up to 6,30,720 units, but it produced only 5,82,773. Okay, but it's not bad because while taking this plant performance factor, it is producing 92%. 92% plant performance is there. It's more than I think so for a solar power plant. Okay, and you can see there's actual generation and estimated there's projected generation. So here the red indication is nothing but estimated power, and the blue indication is nothing but actual generation. So at the time of January, it's reached to near to that one, and February it is crossed. So you can see this graph. So it's more than estimated power. The March time is more summertime, so it's also crosses the estimated power, and April and May. And you can see this comparison between estimated and the actual. So see here July and August. So they had to produce like this, but we are not consider the here irradiation value. We are just taking the plant capacity and its module efficiency and number of hours. Based upon that one, we are given this projected generation, not based upon the irradiation value. So here the season is changed, irradiation also changes. That's why here generation will be less. And here you can see the monthly variation generation comparison report. Here, this projected units given by the particular installer company. So this was taken as a reference. And this data is taken from the FlexiMC online communication. From the online communication, we are taken this 49,749 at the time. Okay, but this will be not accurate because it's in a communication system based. The main thing, communication. What is the status of that inverter? So what is it generating or not? So if it's any fault occurred, what is the voltage level? If any disturbance occurred, what is the current level? So those kind of data, but so for analysis purpose, not accurate. So for accurate purpose, again we will collect from the inverter. Already we are saying no, the digital meter is there. So from the digital meter, we will connect the inverter generation status. Okay, so this is the projected and this is the actual generation values. Well, difference in between these two is like this. So minus 4,000. Actually, it has to produce 68,000. So the difference is 4,921 is there. So percentage in percentage wise, we can find this. What is the percentage difference? So this is one of the analysis report for comparing the projected units and actual generating units. And this is the same comparison report in graphical representation. Here the blue indication nothing but FlexiMC. It is taken from the FlexiMC, and the red indication is nothing but projected, and this is taken from the inverter. See, and the actual inverter data. So there is a lot of difference will be there. So main thing why I'm showing this one is we cannot identify the exact values from the digital communication. Okay, because some communication disturbance may be occurs because it may be that what are the generation data or everything will be passed to the cloud. From the cloud, we will get that to the website. Is it? So that time the communication maybe gets some difference. Okay, so that's why so communication data will be not taken for the analysis. So accurate data will be taken for the analysis, and is there any status, inverter status or actual generation, what is the present generation status, or is the running hours, those kind of data we can take in from the communication devices. So this is a typical radiation map. The simple one, everyone knows this one. From morning we will have the less radiation. Whenever it reaches to the afternoon time, it will be reaches to the maximum point, and again so goes on. At the evening time, the radiation will be reduces. So why I'm showing this one means for this analysis purpose. You can see the performance ratio calculation of solar PV plant. each module having the area of 1.75 meter square. So total number of panels are 1250. Efficiency of energy conversion of each module is 18%. And area of total modules, so each module having 1.75. Total number of modules are 1250. Then total area of the module is 2185.75. Here consider, so previous one only. So there we are just analyzed that what is the capacity of plant and energy conversion ratio efficiency and number of hours. But here we need to consider a proper analysis purpose. We need to consider the radiation value. Then only we can get the exact performance ratio. Here I can say this one. So what is the solar actual generation is 58,254, but they are given that projected in 63,524. So I'm start at the beginning time. I'm told that before erecting a power plant, so we need an this analysis report. That's what is the temperature, what is the irradiation value for a 1 year span, what is the wind speed, highest wind speed, and what is the lowest wind speed. So those data we require. So based upon the data, they will give this projected units. So last 2 years, March time, they have some radiation value. So based upon the sorry, based upon that radiation value, they will take an average value and they will give them projected units. So based upon your site location, so this module may produce 63,000 units. But at the present situation, it produces only 58,000 units only. So why? Because it's having the radiation values 179.40. So based upon this radiation and the solar module generated power, so this plant shown the performance is 82.53. That means its performance is 82% only, means we can improve the performance. Yeah, it is a chance by maintaining the proper maintenance schedules, like cleaning the panels. Is there any loose connections like this? So by taking this maintenance schedule, so main particular solar power plant efficiency improvements means by cleaning the modules only, we can improve the efficiency. Okay, so here we got this analysis. Here the performance is 82%, 81%, like that. So at the time we may go to the particular site and taking the cleaning session, and after cleaning, so its performance maybe increases, and also it depends upon the irradiation value also. That is the main thing. So in this analysis, we can see here, so irradiation values changes 162, here generated only 51. So here you can see this 158 at the time of May 2019. It's given of 49. So projected is 56. Its performance is only 79 is there. Okay, so like that overall, so plant performance in the span of 1 year, it's given 5,65,000. So here it's given the projected is 5,83,000. It's almost near to this one. So plant performance is 83.49. So for calculating the plant performance, no need to consider this projected units. We need to consider actual generation and radiation value. Okay, so those calculations I will show in the next after 2 slides. So this is a month-wise radiation versus performance ratio. So you can see the graphical representation. Here the blue indication is nothing but radiation per month-wise, and here the performance. So month-wise plant performance, so 82%. At the time of June we got 88%, and in February also it crossed the 88%. So with this graphical representation, we can identify where is the fault, is there any problem in that site, so we need to improve the maintenance or anything. So with the help of this plant performance graph only, we can identify that. So here 1 month plant performance, so day wise, every day. So January 1st, it is having the radiation 4.31. So at the time it's produced 310 kilowatt only. So performance only 64%. So here you can see second. So almost the same radiation, but it produced 1,563 because already I'm told now. So here we are seeing that January 1st, it's a very less performance is there. Something is a problem in that particular site. So we are going to that particular site, and we are seeing that most of the panels are fully covered with the dust. So then again, we are gone for the maintenance by cleaning the total models. Then next day, it's improved its performance values. So this all things we can monitor from the FlexMC online communication system. So every day we can check the plant performance. What is the status? What is the problem? Everything we can get. At the same time, we can see the day-wise performance. So here you can see the generation. So this is the generation levels, and this is the plant performance percentage wise, day wise. Here answer the plant performance calculation. I will show in the next two slides. So this is the slide. So you can see this plant performance ratio of the plant for a period of time. So energy measured, whatever the energy previously was in 58,000 units, is it? So that unit, 58,000, or you can see the example here, 56 of in the span of 1 year. So 5,65,390. So irradiation value. So in denominator, we will multiply irradiation value and active area of PV modules and PV module efficiency, that is 18%. So by considering these values, you can find the plant performance and the plant utilization factor. So plant measured by 365 days into 24/7 installed capacity of the plant. So here the installed capacity is 400 kilowatt. So plant utilization factor is 16%. Next one, day-wise generation, radiation, and performance ratio. So day-wise, what is the generation? So you can see the generation, and till now, in that particular site, what is the generation power, generated power, and on the take, what is the irradiation value? So overall performance. So already I'm shown the formula now. So for that calculating this plant performance, we required this data: panel area, total number of panels, and efficiency of energy conversion, and total number of modules. So we need a weather report also. So that means a weather monitoring system. What is the irradiation value of global horizontal irradiation? So irradiation value, humidity, module temperature, ambient temperature. So main for solar power plant, main criteria is irradiation only. But this module temperature also improves the performance. There's a chance. Because recently we have seen some floating solar power plants. That means modules are placed in a river or lake like that. So by reducing the temperature of modules, so we can improve the performance also. There is a chance. So that's why. So here we are monitoring that module temperature and an ambient temperature also. But major criteria is irradiation only. Okay. And from the site we can get the AC current and AC voltages minute to minute. So I am already told that now if any fault occurred, if any problem occurred in a particular site, so we can go and check that what is the problem. But we cannot identify the situation. Is there any module failure or inverter, any array failures are there. We cannot identify that one. Then we will go to this point. So here we can see the minute to minute. So if there any problem occurs, then here we can get the data. So here one phase having the highest voltage, another two phase having the two different voltages. So there is an imbalance in the three-phase system. So we can identify that one. Also there is an power imbalance voltage is there. So we need to consult the substation person. So is there any incoming failures? Are there any load shedding also? Are there load scheduling are there? So like that information we can get by monitoring this AC current and AC voltages. At the same time, DC voltage, what is the solar power plant generation, present voltage, how much voltage is maintaining. So if a voltage is less means some module may be damaged or some module may be having a loose connections like that. So we can identify by monitoring this DC voltage and the DC current. At the same time, we can get this information AC power and DC power minute to minute. Everything will be minute to minute only. And also frequency. What is the status of frequency? So till now we have seen that power generation and how to monitor. So what is the performance of particular site? Here we can see the measuring of the generation and exporting and importing of power. So those topic we will see in a 2-meter configuration. So here you can see that PV solar array. From here it is connected to the combiner box, that is nothing but array box. So we are already seen that one, and is connected to the DC disconnected switch. From there, so this is only for the protection purpose. Okay, and from there it is connected to the inverter. From the inverter, the AC supply is given to the AC disconnected switch, nothing but breaker like that. Okay, here the monitoring purpose. So this is inbuilt in the inverter. So this is nothing but a breaker. From there, it is connected to the main consumer panel. So already I'm told now. So ACDB, so AC distribution board is there. From there, it is connected to the each block separate MCB will be there. So that is nothing but here main consumer panel will be there. From there, it is connected in parallel form. One is connected to the local area consumers. Another is connected to the grid. If there any requirement in the local area, that means based upon the demand condition. So if the generation is equal to the local demand, then total consumption will be load side only. So nothing power will be passed to the grid. If a load consumption is very less, then whatever the power utilized, remaining power will be sent to the grid. So through the utility meter, that is nothing but bidirectional meter. Okay. So here simply it will records how much power you are exporting to the grid. So every month we will do an analysis report, how much power we have sent to the grid and how much power we are taken from the grid and how much power we are generated from the solar power plant. Well, taking this February month. Why I'm taking February month? This is before the lockdown period. So after lockdown, some calculations changed. So that's why I'm taking for easy analysis purpose. I'm taking the February month report. So here units generated from solar online data. That means Flexi MC. From a Flexi MC we are taken. So this data, generated data, 55,000. This is taken from the inverter. There is no much difference, almost in the same. Already so digital communication. So that's why here I'm taking the inverter data as the main one. So difference between this two is 93 only. And this is the major one. So please listen carefully because so from the AP special, so I'm given I'm told that bidirectional meter, utility meter. So bidirectional, here they will measure both import and export. So both data will be recorded. Is it? So this is AP special imported. That means we are taken from the grid. How many units are there? 40,248. So main thing, government side, if they are calculating the electricity bill, they will consider only kVAH only, not kWh. Because this is multiplied with the power factor. The power factor will be based upon our loads. Basically, our loads are inductive loads only. That's why our power factor will be always low with lagging only. Okay. So due to our load fault, they are not going to bear that amount. Okay, so that's why. So they will calculate the unit charge only for kVAH, not for kWh. Okay, so they are taking that how many units? We are taking how many units? 42,000 units we are taken from the grid, and here export units are there. That means we are given to the grid. How many units we are given to the grid? So 4,648 kWh and 9,472 kVH. Okay, and this is the another major important reading. There is a TOD, time of day. That means peak time. Okay, so at the evening times, load consumption will be peak time. Okay, so that time, so consumption will be more. So that's why they will charge extra 1 rupee for this TOD reading. Okay. So here the cumulative power generation and consumption report. So generation and consumption report, everything we will get from here. So number of units imported from APSPDCL as already we are seeing here. So this is a, so here you can see the explanation also. I'm kept the explanation also here. You can get a clear identification. The number of units exported to APSPDCL. So we are given the power to the government. That is represented with B. So number of units consumed with normal tariff. So here main thing, this is the consumption charges. So while they are preparing a bill, so they will consider so how much power we are given to that particular organization and how much power we are taken from that organization. By taking the difference of these two, finally they will charge this amount. So here I am written the explanation A minus B. So 42,000 minus they will calculate for kWh in generation side. Okay. So 9,468. Then finally we will get 32,536 units. So they will charge for these units. Okay. And the minimum number of units charged means sometimes we will get less than 7,000 units sometimes. So that means welcome to the semester break or summer holidays time. So consumption will be very less. So that time, so for example, government given only 10,000 units. That time you are given 5,000 units, for example. So net balance is 5,000 only, but they will not give the bill for the 5,000. So minimum units must be 7,000 only. So less than 7,000 means they will charge for 7,000 fix. After that, 7,001 unit means they will charge for only 7,001 unit. Okay, like that. So that situation also happened. I will show in the next slide. So total number of TOD readings are so 11,000. Sorry. So total number of units TOD readings are so 11,644. So they will charge 1 rupee for this each unit. So this also comes under this import reading only, but additionally they will charge 1 rupee for this units. And number of units charged by APSPDCL with a normal tariff. With a normal tariff 32,536. Here I am written this one, same thing. And the number of units generated from the solar power plant is 55,449. And the total number of units consumed from APSPDCL and solar power plant. So here, so how many units we are consumed? So this is the data. So we are generated from the solar power plant. We are consumed that power, and also we are taken from the grid. So total consumption of that particular organization is 88,085. Okay, and power factor of that particular grid is 95%. So power factor is, and this is a final calculation. So very useful. The cost of electricity bill with normal tariff. Already I'm shown this now. So 32,536. 32,536 into each unit cost is 7.65. So you know the tariff concept. So like industries, organizations, institutes. So government will provide flat rate tariff. So how many units you are consumed? You may consume 1 unit or you may consume 1,000 or 10,000. Each unit cost is fixed. That is 7 rupees, 65 rupees. So there is a flat rate. Suppose welcome to the household consumers. So the tariff will be block rate tariff. So 1 to 20 units one cost, 20 to 50 units another cost, 50 to 70 units another cost, like that. So this will be household consumers tariff will be block rate, but organization, industries, or any institutes. So government will provide flat rate tariff. That cost will be high somewhat. Okay. So each unit cost is 7 rupees 65 paise. So here we are consumed here 42, but we are given 9,000 units. So the difference is 32,000. So the difference is 32,000. They will charge this 32,563 units for this 32. So 36 into 7.65, we will get 2,48,900. And I am already told you, TOD charges will be a peak time period. So they will charge additional 1 rupee for these units. And the electricity duty charge, how many units you are consumed. So each unit will they will charge 6 paisa. So this will be 1952. And this is most important, demand charge with the normal rate. So it's some lengthy explanation. So I will explain. So here in electricity bill, we have two charges. One is fixed charge, another is running charge. Running charge means how many units you are consumed. That will be charged. This is the fixed charge. Okay, that is not depends upon the load consumption. So this depends upon peak time period. Okay, so here the maximum demand for this institute is 350 kVA. Okay, so if it's having the reading, they will collect the meter range. No? So that time they will record the data. So recorded maximum demand value, how much? If it is less than 280, if it is less than 280, then they will charge for 350 into 80%. Here you can see this minimum 80% of 350. That is 350 into 0.8. 280 kVA. They will charge for 280 kVA. That is a 1,33,000. This is a fixed amount. So you may ask, if it is crosses the 280, what will happen? That means after for 290 kVA. If it reaches up to the 350, so if you got 349, so 349 kVA is there, they will charge for 349 into, so each unit cost, each kVA cost is 475 rupees. Okay, so 475 into 349. So up to 280, so they will charge only for 280 only. So if demand your kVA recorded maximum demand is only 80 is there, but they will charge for 280. If it crosses 280, then they will charge how many demand value, how much demand value is there. If it is a 290, it means 290 into 475. If it is 349, means 349 into 475. If it is crosses 350, then they will charge for penalty. Remaining how many units you are taken, the maximum demand value. So that remaining units will be charged with penalty. If it is reaches 360, then they will calculate for 360 into 475 plus, so 10 is additional. So 350 minus 360 minus 350, that is 10 is additional. 10 into 475, like that. Okay. And consumer charges, it's a fixed one, 1,406 rupees. And finally, so electricity bill for the month of 2020, February month 2020, so 3,97,457 rupees. Okay, so as per SPDCL billing units are 32,536. So January month bill is 2,82,000 because it's a semester beginning. So that time consumption is somewhat low. That's why here 2,82,000. And February month, there is no holidays. In the month of January, more number of holidays and semester beginning. So that's why consumption will be low somewhat. So in month of February, there is no holidays. So semester mid period. So that's why consumption will be more, 3,97,000. While comparing with the last month bill, so bill amount is increased to 1,15,000. And already I'm told now if exported units are more than the imported units. So here you can see the situation. So this is a lockdown period, April, May. Just leave it this one. I will explain about this one later. First, let's see the January and December. So here you can see this consumption generation is 53,000 units are there. So projected is 52. So more than that we got the generation. And here demand is reached to all. I'm already told you, recorded maximum demand will be there. So that is here 151. So only 43%, but they're consumed 1,33,000 rupees because 350 into 80%. That means 350 into 0.8 into 475. So you will get 1,33,000. That is a fixed one. You cannot change this one. And energy consumption, you can see here 7,000 because at that time, so consumption units are, so that means imported units are more than exported units are more than imported units. So we are given more units to the government. So that's why they're charged for only 7,000. Here you can see there's 53,000 common at every point. Because 53,000 means 7,000 into 7.65 rupees. So that's why they are charged this common amount. Demand charge is fixed and this amount also fixed. So that's why here we can say nearly 2 lakhs amount every month bill. This is minimum. So yeah, we are consuming the less power. We are generating the more power. That situation also, we need to pay minimum 2 lakhs to the government. So you can see this before solar power plant installation. So here you can get that an idea. So here you can see this maximum demand is 350, but recorded is 381. So 109%. So you can see here they are not charged this fixed amount 1,33,000. They are charged for 181. That means 381 into 475. So that's why it's came 1,81,000. Remaining this 31 units, they are taking the penalty, additional charge. Each unit, the 31 into 475 rupees. This is the amount. Okay. And energy consumed. So consumption charge is 6,51,000. So finally, the total amount in the month of July 2017 is 8.7 lakhs. So you can see this time also. April, in the time of April, 10.8 lakhs is there. It's an electricity bill, 10.8 lakhs. So in the span of this 22 months, so total electricity bill is 1 crore 51 lakhs 36,000. Electricity bill is 1 crore 51 lakhs 36,000. So particularly the consumption, only this is a running charge. Only running charge is 1 crore 14 lakhs 45,993 rupees. This is the amount they are paid before erecting the solar power plant. Okay, so same thing. So for the span of same 22 months, if I taken for the after solar power plant erection, you can see here 98 lakhs after erecting the solar power plant. Before erecting the solar power plant, 1 crore 51 lakhs are there. So now after erecting the solar power plant, it is reduced to 98 lakhs. That means, so don't think that's 98 lakhs. How much amount is reduced? You have to compare this one. 1 crore 51 lakhs is there. After erecting the solar power plant, it is reduced to 98 lakhs. Okay, so it is reduced nearly 53 lakhs in the span of 22 months. And here also you can see this consumption charge is having 64 lakhs. Before solar power plant, how much is there? 1 crore 14 lakhs is there. But here consumption charges is reduced to nearly half of that one. So here amount is 53 lakhs difference is there because the demand charge is fixed now. That is the problem here. And unit rate also changed. Here you can see the unit rate is increased at 7.66. Here you can see the unit rate is only 7.3, 7.25. Before erecting the solar power plant, unit cost is also less, but here unit cost is more. Even though, so here the consumption charge is reduced to 50%, nearly to the 50% after erecting an solar power plant. That is the main advantage of a solar power plant. Okay, and you can see in a complete comparison report. So after erecting the 53 lakhs 15,000 difference is there after erecting a solar power plant. Particularly consumption is reduced to 49 lakhs 96,175. Amount is reduced. Though in the span of 22 months before solar system, total bill amount is 1,51,000. Sorry, 1 crore 51 lakhs is there. After erecting a solar power plant in the span of total 22 months, it's a 98 lakhs only. The saved amount due to the solar power plant is 53 lakhs. Average saved amount due to solar power plant is average. So in this month of in the span of 22 months, 53 lakhs is saved. So while calculating for the 22 months, average amount saved for each month is 2 lakhs 41,000. In the beginning, I'm sure no. So every month saving units is 32,000 units are there, and approximate 2 lakhs saving amount is there. In the beginning, I'm shown. So that is the calculation part you can see here. 2,41,000 amounts in every month averagely. And total amount invested on the solar power plant is 2 crores. That is 1 crore 81 lakhs for erecting a solar power plant, and the remaining 20 lakhs for the Flexi MC online communication purpose. So total investment is 2 crores. In that we got 61 lakhs subsidy from the government, and average demand charge saved due to solar power plant is 2 lakhs 21,000. Demand charge is reduced. Here you can see 2 lakhs 21,945. So previously, so before solar acted before erecting solar power plant, many times it's reached more than 280 kVA. So whenever it crosses the 280 kVA, they will charge what is the kVA value is there into 475 rupees. So that time we are paying more amount to the government. So after erecting this solar power plant, we couldn't reach more time at more than 280. You can see here. So we couldn't reach the more time more than 280. So here we can see this two periods remaining almost here one period, here another period. Remaining all are less than 280 only. So you can see here only so 1,33,000. So whenever I reach it at 324, it is charged 1,53,000 like that. Okay, and here also you can say 320 into 475, 1,52,000. Except that 4 months remaining total duration, they are charged to 1,33,000. There is a fixed amount, we cannot change this one also. So that's why, so this demand charge also averagely saved per month 2,21,000. Consumption charges saved due to solar 49 lakhs. So you can see the 49 lakhs 96,000. Based on average saving amount, payback period will 54 months. So averagely we are saving 2,41,000 now. So investment is 2 crores. So 2 crores investment is there. So finally, based upon this analysis, the payback period will be 54,000. Whatever we are amount invested on the solar plant, that amount will be used to 236 kVA. And finally, so let us see the benefits to the company. So cleanest form of energy, highly eco-friendly, reduces carbon footprints, and no requirement of additional land and hence cost. Almost nil running cost, very less maintenance cost. Expectations of stakeholders, companies with low carbon footprints and a low registration period, easy to install, and it creates local jobs. Last one require less skill maintenance. So already I'm told you, maintenance, solar power maintenance means just cleaning is enough, any loose connections are there. So that thing is enough for the maintenance. And benefit to the country, so cleanliness and electrification of remote areas where a grid or distribution network is not available. No load scheduling as power is readily available. Cheaper power available. Low interest loans available. Warranty for a longer duration. Low maintenance cost as there are no moving parts. So there is no moving parts. In case of grid connected solar, excess power can be sold to the grid for commercial benefits. Already we have seen that analysis. Saves transmission distribution losses. Railway platforms may be used for rooftop, solar for additional added advantages, and the rooftop panels may be installed on major installation in areas for generating electricity and increased valuations of homes. So these are the benefits to the country, and we are seeing the benefits to the company also. Okay, so we're thankful to you, everyone. So by showing such interest on this topic, and so everyone shown us such a patience. So thanks to everyone. Do you have any queries? Please ask me.
Thank you so much, sir. Varaprasad sir. Sir, one query they have posted in the starting itself. They are asking that please elaborate on single phase DC generation and converted into three phase AC only by inverter or other machine mechanism. Sir,
Oh, Please elaborate. Yeah, madam.
Yes, sir. They're asking that
Hello.
conversion into three-phase AC only by inverter or any other mechanism.
So inverter is the best choice one, and so fault condition will be low and maintenance also not easy. Well, come to the high conditions. Like first of all, we will go for the inverters. That means we need to convert them from DC to AC. So before that, we have to choose an IGBT step-up choppers and stabilizing that DC at a constant position purpose. We need filters. This much of mechanism is required. Okay, for converting from AC, sorry, DC to AC. So this much of mechanism is unnecessary and more investment. So while choosing an inverter, the simple technique. So inbuilt circuit will be there. So easy to convert and maintenance also less and cheap cost.
Thank you, sir. I request any participants want to interact with the resource person directly. They can unmute yourself. Sir, I think no one is interested to have interaction. The questions also, queries also finished, sir. Thank you very much, sir. Varaprasad, sir.
Okay, thank you, madam.
I request HOD, sir, to give the vote of thanks and valedictory.
Uh, Thank you, Sunita ma'am. First of all, I want to congratulate as well as express my deep thanks to our faculty professor, and the way of explanation also went very well as we expected. Thank you so much, sir, for a wonderful delivery of our rooftop plan.
Thank you, sir. Thank you, sir.
Yes. So I request participants, please provide your feedback on the complete 12 sessions which went. We started from Monday onwards, Monday morning. It will be very helpful for us. Please come forward and you can unmute yourself and share some best experiences during these sessions. I request participants, please.
Okay, good afternoon, sir. Can I hear laudable, sir? Can I hear?
Sir, yes, it's
Yeah, yeah.
clear, sir. Please, sir.
Okay, okay. Good afternoon to all. Myself, Jitendra Kumar Rathod, working as additional executive engineer in MSDCL Maharashtra. Presently, I am posted at Nashik. First of all respected dignitaries and participant on this virtual platform. First of all, congratulations to the managing team of your SV College of Engineering, Tirupati, for organizing the well-structured and AICT-sponsored STTV six-day program on research challenges advancement in renewable energy technology. Really, the topic which you have chosen is the need of today. Future challenges for the young engineers, academicians, and the researchers, and their role, how to mitigate global challenges. All these points are covered in your topic selection, so that is really very much appreciable. And sir, and also I also wish my special appreciation to your team member, your coordinators, for their dedication work throughout all the 6 days to make a program a grand success, their involvement and their proactive approach for conducting this program. The sub and the resource person, what I have seen, you have chosen well in respect of their knowledge and their practical aspect, or you can say their approach. And I am bit confident that the lecture delivered by Dr. Reddy, Dr. Vignesh Kumar, Dr. P. Ramesh and Dr. Deepak Reddy, that will motivate all the participants and that can help us to use our knowledge for the benefit of society. All the other faculties have also delivered the session very effectively. I have seen their holistic approach concept, how to think rather than what to think, and that is definitely very much useful to all of us. So, sir, I can say the aim of program, what you have decided, is definitely come to the truthful and it will be useful to all the learners. And if
Of
I
course,
got
sir.
now the opportunity to express my pleasure that as we are working in Mahavitar, you can say the distribution company in Maharashtra, the largest and longest distribution company, power distribution company, and luckily I am posted at the training center, state level training center. We are conducting also so many training programs and awareness program for the faculty member and the engineering students, such on subject like electrical accident, safety measure, soft skill development, energy conservation. In future, if you need any our help, then we can conduct all this program, your institute webinar on the proactive basis to serve the nation and to serve all the participants. So I once again congratulate the team of ESV College of Engineering Tirupati. I am also thankful to the organizer for giving the opportunity to express my feeling about the such nice program. I wish a good health and best wishes for future work. Take care of yourself and your family. Stay safe. Thank you, sir. Over to you, sir.
Thank you so much, Jitendra Kumar sir. That really sounds good, sir. And your words really filled positive vibrations in all our team. Thank you so much, sir, for your very clear feedback, sir. Sir, of course, and my side, I'm requesting you, sir, in future, as you said, we need your help for providing the service to the nation in perspective of energy side, sir. We
Okay.
will approach you, sir. Kindly, if you share us or drop a mail in our group, sir, either in WhatsApp group or Telegram group, I'll approach you, sir, personally. So thank you so much, sir, for your kindness once again.
Okay,
Thank you, sir,
thank you.
Jitendra Kumar, sir.
Okay, thank you, sir.
Any more other participants wants to share their good experience during the session? It's just a formal interaction kind of thing. Of course, we are going for two more phases, that is 66 days. This is phase one. We are planning in phase two and phase three. So for that, we will be make up ourselves as a best. So it will add some more points for conducting in a better manner in next phase two, phase three. Yeah. One more last time, please. I request anybody interested to share their feedback. Please, we welcome you, sir.
Hello, sir.
Yes,
Am I
ma'am.
audible?
Yes, ma'am. It's audible, ma'am. Please,
Am
ma'am.
I clear now? Sir, good afternoon, sir. I am Rutuja Hivre from Nagpur itself, from GH Raisuni College of Engineering, Nagpur. Sir, I attended this STTP with a view that I want to learn something about the generation system while we are using the renewable sources there. So I am very much thankful to you to organize such type of the STTP that can enhance our knowledge in the field of the renewables. So I can say the thing that the topic is very much relevant, and the whatever the speakers you got for us that are very much give the information, and it was provided the information just like from the basic they told us the whatever the information they are having. So
Yes.
I'm glad that I was there, and I attended all the sessions. Very thank you, sir. Thank you for this.
Thank you, Rutuja ma'am. That's really thankful for your words, positive words, and surely we will just continue in the same phase and same fashion. We will maintain in the next two sessions also. Uh,
Yes.
Thank you so much.
Okay. Thank you. Thank you very much.
Yes. Still, any more participants? Okay. So say vote of thanks. Before that, I would like to deliver a few more instructions because we're just taking a break. It's not end. Um, that is, today you'll be having one more test. That is it will go 30 to 45 minutes. I guess it's 45 minutes duration. So it will start at 4 p.m. and ends at 4:45 p.m. So please, you have to everybody mandatorily as per the AACT rules and norms. So you have to attempt this test. So as per the AACT norms, you should maintain attendance as well as you should get 60% in the test. Okay, don't worry. The test is covers all the sessions at basic level only. So please make a note of this. From 4 to 4:45, you will be having a test, overall test. So please do attempt. If you face any problems, please approach our team. So they will be ready to help at any time. Thank you. Uh, Now it's a time to say vote of thanks. So it's not a saying like a goodbye. So we are coming up with the new technologies and new innovative knowledges. We are going to bring up some more resource persons from outside the country also for the next phases. Please stick with our groups like Telegram group as well as WhatsApp group. I'll post the updates also. So now it's time for vote of thanks. First of all, I would like to thank all the participants who patiently attended our sessions from day one to this sixth day, 12th session. Surely, I'm just thinking that you got some more knowledge. That is before day one, whatever may be the knowledge. So now today, I guess at least you got some improvement in your research area. So with that assumptions, I'm going for participants. And secondly, the total team, the team which supported for this complete session. So it's not only 3 to 4 members. So all the department faculty have worked behind the screen, and they maintained in such a manner that our theme is like only quality with at a particular instance, that is with the duration, time maintenance, everything. So with that theme, we just thank each and every department faculty behind this particular who helped, like our technical team, promoting team, and quiz making team, other financial team, so guest inviting team, resource person inviting team. So all the teams, I heartfully thank from our SV College of Management and from principal's side. I heartfully thank to everybody who supported this event. Finally, participants from our College of Management side, SV College of Engineering Management side, and from principal's perspective, I heartfully thank all the participants who patiently attended all the 12 sessions. We are sure in future also we will continue the same quality with improved feedback given by Jitendra Kumar sir and Rujita ma'am. We'll maintain the quality. Thank you. And before leaving, happy Dasara to everyone. Stay safe and stay healthy. Thank you. Thank you all. And before leaving, the final word, Sunita ma'am and Kumar sir, you did wonderful job. Uh, you spent all the time during the night time also. You got a calls. I know. Uh, Finally, we received the feedback in such a manner that we maintained the time. So that is a thing behind the success of anything. Thank you, Sunita ma'am. Thank you, Kumar sir.
Thank you so much, sir. Dear participants, I am announcing again. Before 4:45, fill the feedback forms. Please share your valuable feedback and quiz also within time. Thank you, everyone.